Hi, everyone. Thank you for joining us today for our webinar, How Cincinnati Built the Smartest Sewer System in the World. I'm Jeremy Boren. I'm the brand manager at GrayMatter, and I'll be your moderator for today's webinar. Thanks for joining us today. We're going to start off with a few tips to enhance your webinar experience. We really recommend you close your email, any instant messengers you might have, like Slack, and any other programs that you're not really using right now that could interfere with the smooth reception of the webinar, cause some slide buffering, or any poor sound quality. If you need help as we go along, there's technical assistance that you can find at the GoToWebinar technical support page. There's a link there listed for you on the handouts and in the slide that's being shown right now. As soon as you close the GoToWebinar screen and you leave the webinar, a window is going to pop open with a survey questionnaire. We really ask that you go ahead and complete the survey. Helps us learn from what we do and perfect it for next time. So look for that survey. Also, we encourage everybody to pick one person to kind of enter collective responses to the survey. And then submit them to us. Also, just a quick disclaimer here, just so everybody knows that nothing on here is an endorsement from AWWA. They don't endorse or approve any of the products or services. Also, just a quick note from GrayMatter on December 5th, we're going to be giving a tech talk and tour at Bonita Springs Utilities. You can sign up at graymattersystems.com under our events page. So with that, I'm pleased to introduce our distinguished panel today of experts for today's program. Today we have Alan Hitchman of GrayMatter and also Reese Johnson of the Metro Sewer District of Greater Cincinnati. Cincinnati prioritizes investments in technology to run the smartest sewer system in the world. And this webinar is really going to offer some insights into how you can take a data-driven approach to produce savings without having to invest too heavily in gray or green capital expenditures. So our panel is going to be happy to answer any of your questions. Feel free to submit questions anytime throughout today's webinar broadcast by using the question pane at the lower right-hand part of your screen. Please include your name and the name of the panelist that you want to direct the question to, or I'll do my best to kind of suss out who the question might be best suited for. And we have a quick agenda there on your screen as well to kind of give you a sense of how today's presentation is going to go, starting off with Alan and then going over to Reese. So with that, I'd like to introduce Alan Hitchman. He's the Chief Revenue Officer of GrayMatter, and Alan's going to be talking about GrayMatter's work in the water and wastewater industry and how we've really developed a really cool collaborative relationship with Cincinnati and with Reese on this really exciting project. So with that, Alan, take it away.
Thank you, Jeremy. It's an exciting thing to talk about here. GrayMatter had been involved with City of Cincinnati since probably over a decade, and to see it evolve into this and everything that Reese has been doing under his last couple of years of leadership at Cincinnati, it's certainly an exciting topic. So what GrayMatter does is kind of a three-prong approach. What we do is we help water and wastewater customers through our consulting business, and we've got folks located across the U.S. and Canada that are either practitioners, come out of water utilities, have come out of consultants, or are technologists across many of our curated products that we bring in. And we basically can help everything from a very practical way of how do you do data science, how do you create a 3, 5, 10-year plan around technology, how do you take your OTIT and begin to morph those together. And so we've got a practice that does that. When you look at our implementation services, typically these are around data science or very what we call specialty things. We're not a system integrator. We don't have folks that go and do calibrations or anything like that. What we really do is we focus in on if you need an advanced alarm strategy, or you need something like Reese is going to talk about, and you have to have some very deep building, very deep technology done. GrayMatter can help you do that, and in some cases we do that in support of system integrators and consultants. And so it's a great opportunity to bring in just some very deep expertise around everything from the things we're going to talk about today to kind of the structure of how you want your IT system. And then the last piece, we do represent a number of different brands, the largest one being the General Electric business. You'll hear a lot about them today. And that's kind of the things that we bring to bear. So we've got a bunch of products around that for the water industry. The kind of 6 areas that we operate in then, to get a little bit more detailed here, is how do you become kind of a data-driven organization? And we've got a single pane of glass kind of approach. We also have folks that are authors in a number of ISA standards like ISA 101 and high performance screens. We do a lot of work around connectivity. And then cyber is a really big thing for folks these days. And we actually have an entire team of cyber engineers and specialists in that area. So a lot of great kind of things that we can bring in to bear for municipal customers. And then the folks that we work with, it's roughly 1,000 water, wastewater utilities across the U.S. and Canada. We have offices in Florida, Toronto, Denver, California, Texas, and Philadelphia or Pittsburgh. So our ability to kind of reach around all of the spaces that we have, kind of bring best practices, not only what's going on in the East or West U.S., but what's going on in Canada, kind of helps out there. And so we kind of really drive into how do we help you manage your assets in a great way? How do we help you scale and grow across the community? And then ultimately, how do you solve through a number of challenges, whether that's non-revenue water or leakage or any of those things? So a lot of great things kind of come out of that. And then to kind of kick off what Reese is going to talk about, we've been at the city of Cincinnati, I guess almost since 2007, and continue there today. And our responsibilities have gone from working with them across a number of revisions of iFix and the Historian products to a lot of things that they're doing in the cloud. But also we've got folks that report there every single day. They continue to maintain and develop new things in the system. And Reese will go into a lot of reasons why this was done, but Cincinnati was facing a huge challenge around how do they get out of spending and building a tunneling system. And Bijou George, in his tenure there, came up with a brilliant idea to how do we leverage technology, and ultimately that led to all of the things that you see on the screen there, and just an incredible kind of world-class way of approaching overflows in the sewer. So without any further discussion, let me tell you a little bit about my friend Reese. He's a former CH2M Hill employee, and then moved over to manage the City of Cincinnati's wet weather program. But above all that, he's an innovator. He's a speaker. He does a lot of things inside of the water wastewater community, and I'm happy that he's a good friend of mine. So Reese, I will turn it over to you.
Hey, thanks, Alan. Hi, everybody. Now that you've heard a bit about some of the neat things that GrayMatter is doing with us, and they do that with others as well, I'd like to tell you a story. And that story is about the sewers in Cincinnati, Ohio, and how the Metropolitan Sewer District of Greater Cincinnati has turned our sewers into one of the smartest sewers in the world. So let me set the scene here for our story. Chapter 1. Our story is set in a quiet little corner of Ohio. MSD serves Hamilton County and portions of the neighboring counties in the southwest Ohio. We serve over 800,000 people across a service area of about 290 square miles. It's shown there in green on your screen, which includes the city of Cincinnati, which is shown in yellow. And we have over 3,000 miles of sewers, a lot of which are combined sewers, shown there in red. And those are they're going to be a key part of our story. And on a quiet day, meaning when it's not raining, we treat upwards of 184 million gallons. But actually, it's not so quiet of a corner here in Hamilton County. When it rains, which it does a fair bit, our sewers overflow. We have over 250 constructed overflow points in our system. And here at the beginning of our story, we were overflowing an estimated 11 billion, with a B, gallons in a typical year from all these 250 overflow points. And none of us were happy with that, least of all, of course, the EPA. So in 2002 and 2003 and 2004, we were in negotiations with the EPA and entered in a consent decree, which landed us got us started on a wet weather program with a price tag of $3.1 billion that was going to take us over the next couple decades of spending on our wet weather assets. And if I may, I'll say that the consent decree is the antagonist here in our story. But many cities out there with combined systems are living this same exact story. So what's the big deal about Cincinnati? What's so special? Why am I listening to this? What's unique about Cincinnati is that we found a new path, and Alan alluded to the earlier steps that were taken by our former deputy director to put us on this new path that was to follow in parallel to our consent decree driven wet weather improvements that offered a new way to achieve compliance. And that journey was launched by a simple question. What if we could control our collection system like we control our treatment plant, and have been doing that for decades, and balance those operations system-wide for maximum benefit? That was the question. And our answer, which ended up being very technology driven, our answer was an approach we called operational optimization. And it's what led us to build our smart sewer system. But before I want to get any farther in our story, you need to understand the players. So the first thing that MSD did was create a new operating division under the Deputy Director for Operations that served as the home for our wet weather facilities and our green infrastructure installations, or as we call them, our stormwater control measures. These are unique assets that are mandated by the consent decree, designed specifically to deal with wet weather, and they have unique operational and maintenance needs, and they needed a home outside the traditional silos of treatment and collection. As we built out our smart sewer system, we incorporated our remote monitoring group and our modeling group in this division because we were using that information, we were tying in that data and expanding the use of our hydraulic model to serve our purpose. And most recently, we also included our pump stations to the family of watershed operations because as remote assets outside the fence line, their operation really affects what's happening in the collection system. So now we have our characters. Chapter 2, turn on the lights. If we're going to control our sewers, we have to see what's going on. So we partnered with the US EPA on a sensor challenge. This was essentially a call to anybody and everybody who had an idea about how to put sensors out in a sewer system. Because we knew if we're going to collect data and control this system that is over 3,000 miles long, we were going to need a lot of sensors. We had things turned in on the back of napkins. We had some wild and crazy ideas. So we took those in, and then we began piloting with multiple technology providers. And from that, we were able to put out a competitive RFP out on the street and selected the proposal that offered us a standard remote telemetry unit that could talk with multiple kinds of sensors, could do secure data transfer, and could buffer that data. All things that were really critical for this system to be able to work. And lastly, and most importantly, it integrated with our SCADA system, where it's monitored, and that allows us to dispatch field crews as needed for maintenance. And I'll get to why that's super important in a minute. But what that enabled us to do is deploy sensors, first to cover our main interceptors, then some of the major trunk lines, then most of the trunk lines, and ultimately until the entire basin is covered. Now, one caveat here, this doesn't mean we have a sensor in every single manhole. That would be cost prohibitive and overkill. But what this means is that we have a good understanding of what's happening in a fair portion of our collection system and know where flows are beginning to build, and we have sensors at the key locations so we can tell what's going on in our system. The result is that today we have over 600 sensors in the field. We're collecting 250,000 data points a day. And over these years, we have quadrupled our fleet of sensors. We started with 150 in 2013 and now have over 600. And we've cut our maintenance costs in half from $4.5 to $2.5 million. So now we are buried in data, but that is not what's made us any smarter. Chapter 3. We needed to transform that data into information if we were going to be smarter. And so here's where GE Digital's tools and GrayMatter Systems Assistance enter the story. We took all these remote data sources into a cloud-based data system. So we have level sensors, we have flow monitors, stream gauges, rain gauges, our pump stations, remote facilities, even our treatment plants are pulled into this cloud-based SCADA system. And there's 2 points I want to make about this system. One, it's cloud-based, and 2, it's a SCADA system. Now first, why is the SCADA system important? SCADA, supervisory control and data acquisition, by definition, is not just data acquisition. It's supervisory control and data acquisition. There are plenty of monitoring systems out there. There are proprietary ones, some that are not so proprietary, but regardless, they are monitoring systems. They are not control systems. We knew from the very beginning that we were going to want to not only collect data, but then use that data to control facilities out in the system. We needed to have secure two-way communications that enables a control system. So hence a SCADA system. The second piece I want to highlight is that it's cloud-based. That's an important piece. It's a scary piece, but it's an important piece because you see all the users on the right-hand side, our engineers, our operators, our maintenance crews, and even the folks that we need to produce reports for. They don't live, all in the same place sitting in front of a screen all day, every day. They need to be able to access this from where they are, which cloud-based enabled us to visualize our information and turn this data into information on regular computer screen, tablets, even phones. Now, I'm probably the coolest guy at a party because I can pull up the sewer system on my phone. It's a great party trick. But what really this enables us to do is empower all the people who need access to this information to get it where they are, whether they're in the field, in a control room, at their desk, or wherever. So now I can see, and not only can I see, but I can make sense out of the information that I'm collecting. Here's an iFix SCADA screen for our central watershed. It shows our overflow points, it shows our monitoring points, it shows facilities all in relationship to each other, not geographically accurate, but all together in a way that we can begin to make sense of what's happening in our system. More importantly, I can intuitively see where my system is stressed. Here's a screenshot from another watershed. And none of you, probably very few of you, have ever seen my SCADA system. And you can see very quickly that we have 5 spots that are in trouble. There's 5 red boxes on this. And the beauty of the SCADA graphics is be able to intuitively show show data that turns that into information for a manager or an operator to take action on. I can see very quickly that my system is stressed, and then and that there are some places that aren't stressed at all and other places that are beginning to get stressed, the yellow. So intuitively, you're able to see what's going on in this system. Remember this slide. I'll come back to it because it highlights a couple of examples of how we've leveraged our smart sewer system. But we need to move on with our story. So chapter 4, reaping the benefits. The benefit of a smart sewer system isn't just having visibility. Ultimately, it's to improve operations. So we used the data we were collecting to make 4 of our wet weather assets smarter and perform better. In the first year, when we had just added real-time monitoring capabilities to these 4 systems through our cloud-based SCADA system, we improved their performance by 15%. That means they were capturing 15% more flow than they had prior to us adding these capabilities, just because we added the SCADA system. In the second year, we added real-time control capabilities. That means not only could we see what was going on at the facility, but we could remotely control what happened at the facilities. And even though 2016, the second year of this study, was a drier year, from a percentage basis, we were able to further improve their performance. I don't know an engineer or an operator or anybody who wouldn't like to hear that you could take a 10-year-old facility and improve its performance 15 to maybe 30% without a major capital investment. Here's another example of how we reap the benefit of a smart sewer system. This is a screenshot from an overflow point in our system, and the overflow elevation is shown with the red line. Okay. The blue line is the level inside the sewer. And the green line there is there to distract you, so just ignore it for now. This is a critical overflow point in our system, and there are dischargers upstream of this overflow point, which we have an agreement with that we can control, that we have a negotiated agreement with. So when the sewer begins to overflow, meaning the sewer line is greater than the overflow elevation, the SCADA system detects that automatically and sets restricted conditions automatically. And then it sends a signal out to a remote control box out at their facility that tells them, hey, you no longer can discharge upstream of this overflow point. You need to haul this particular waste all the way to the treatment plant. And not just a light, going from red to green out there in the boonies, but actually emails and texts go out to the guards, the drivers, the Mill Creek plant operators, their leadership, management, inspectors, investigators, everybody who needs to know that the conditions have changed in the sewer system are alerted automatically. And we've done this through leveraging the GE Digital platform to be able to detect this, set these conditions, change the signal, and send out alerts. This means that highest strength waste gets full treatment, and it has no opportunity to potentially be discharged through this overflow point when those conditions permit. Now, this is an important thing to work out with your industrial discharger because this costs them money, right? They have to now haul their waste twice as far. But we've been able to work with them to say, only during the times where this is a threat do you need to haul that extra distance. Otherwise, business as usual. Let me give you another example of how our smart sewer system provides us benefits. Here's a schematic of a remote treatment facility in one of our watersheds. It is tucked up alongside the river, and the flow generally here is from the upper right corner down to the lower left corner. And this facility was built at this location to keep this manhole over here in the big red circle from overflowing. That's why it was built. We have pumps, we have large storage tanks, and we have a treatment train underneath this arrow. That's why it was built. Now, that facility is way up here. That's about 15 or 16 miles away from our main treatment plant down here at called the Mill Creek Treatment Plant. And the black line there with the dots on it is the interceptor that connects the two. And through the smart sewer system and putting sensors in, we were be able to put sensors all along that interceptor. This red dot signifies the manhole that was overflowing that this facility was built to stop. And what was enabling from the smart sewer system was the fact that we had these sensors downstream. So now this facility not only could keep that manhole from overflowing, but can be used to keep this interceptor less surcharged. And what that means is that all the CSOs that are downstream of that remote facility, dozens and dozens and dozens of CSOs downstream, now have more capacity in the interceptor and overflow less, because the facility at the top can now essentially treat before the water gets down where it's going to overflow. We pulled that into our SCADA system, and since the SCADA system now sees data from these downstream manholes, the facility can now alter its operations automatically without operator intervention to take more flow into the facility, treat it as necessary, and that means less flow goes down and clogs the interceptor. This is shown to save us over 247 million gallons of overflow, combined sewer overflow in a typical year. Now that's on top of its original purpose, which was to keep this manhole from overflowing. I've shared some of the benefits, and as Alan alluded to, there are some costs, and it's important to understand where that cost-benefit analysis comes out. For us, it came out extremely well. When we looked at all the costs that we had invested to get to these capabilities that I've shown to you today, and weighed that against the benefits that we had gotten at that point by improving those 4 facilities, by reducing overflows, we did a kind of a cost-benefit analysis of how much it costs per gallon, because that was a good way for us to compare apples and apples with other things that we were building. Because it's not like we're looking for a return on investment. What we're looking for is the most cost-effective way to reduce overflows, because we have to reduce overflows gallon by gallon by gallon. And what this graph illustrates is that while you may argue with me whether a full treatment plant's ballparked at $1 per gallon or 80 cents a gallon, what this illustrates is that when we ran the numbers, operational optimization, putting in a smart sewer system, putting technology on top of existing infrastructure, we were removing overflows at 1 penny per gallon, a significant cost savings from traditional gray assets to do the same thing. So that's our story, but we're not done writing it. We want to turn our story into a saga. And there are 3 things that we are currently working on to further benefit from the smart sewer system. And they're looking for additional opportunities to reduce overflows, modifying existing wet weather facilities to use these new operational capabilities that I've shown you, and then ultimately to adapt future wet weather projects to take advantage of this new strategy. So let me give you some examples. Remember this slide? Very intuitively, you're seeing that 5 CSOs are overflowing. Well, look at the round circles nearby them where they're connecting to. They're not all full. Because we have data, and because we're able to visualize that data next to data that is related to it, what we're seeing is something that's non-intuitive. We are having overflows when there is still room in our interceptors, because we're looking at the data in real time and seeing at that moment what is happening. And so we are able to take that data we plot that out. See this gray line? That is the capacity of the interceptor at that point. This red line is the flow at an overflow point connected to the interceptor at that point. And the blue line is the water level in that interceptor at that point. And what it illustrates is what that other graph, what the screenshot from SCADA was showing us, that we are having overflows despite capacity in the interceptor. And now we can see it, we can begin to hone in on it, and look at better ways to avoid this. Traditionally, CSOs are very passive structures. They have a dam or a weir and a fixed underflow pipe that goes to an interceptor. Here's 3 examples. If it's raining upstream of a CSO, it rains, it overflows, and only so much can get in the interceptor, regardless if that interceptor is full. What we're doing to target these places that we've identified where there's capacity in the interceptor, yet we are overflowing, is a strategy called dynamic underflow control, where we put gates, controllable gates, and upsized underflow pipes at targeted CSOs so that when there is capacity in the interceptor, we're able to open up these gates and take the flow and not have the overflow. We did an analysis of the 134 CSOs that are in our Mill Creek service area, and putting facilities like this at the top 5 of them would reduce overflow volume another 134 million gallons in a typical year. A great improvement with minimal investment. Remember this slide where we saw CSOs activating and manholes showing that there was capacity in the interceptor? This also allows me to highlight an example where we have remote wet weather facilities, one called the Mitchell RTC and one called the Ross Run RTC, which are facilities that we can control the flows in our trunk lines. It allows us to build in-stream storage. What we've done is taken those facilities and put them into a system that uses market-based optimization, meaning all of them are essentially trading on a market that is enabled by the smart sewer system. Because these facilities don't talk directly to each other. This graph shows all of our controllable facilities in that watershed, and they don't talk directly to each other. All of them, though, are using the same interceptor for their conveyance capacity. So the conveyance capacity becomes a commodity that they all want to buy. So we've tied these together by using the smart SCADA system. They are able to see the levels or the lack of conveyance capacity in the various interceptors that they drain to, and make operational decisions based on that. Again, no additional infrastructure costs, but we're able to reduce overflows by another 60 million gallons in a typical year because the facilities essentially are now smarter. They're talking to each other and sharing information that before they didn't have access to. Quick example, the Ross Run RTC facility, which is shown here in our SCADA system, and our Mitchell RTC facility, shown here in our SCADA system, they each have an underflow gate circled in red. And what happens in this market-based optimization is that right now, this facility, which isn't overflowing because the level isn't higher than the dam here, this gate should be closed. It has room to spare. Conversely, this facility, which is overflowing, its gates should be open. But based on their original logic, it's the reverse. So we're excited about implementing this new logic, again, enabled by the fact that we can get data to it from remote locations. And now these facilities can be smarter, and they can say, you know what, conveyance in the downstream interceptor is limited. The facility that is about to or is overflowing, that's the facility that should get that conveyance capacity, and the facility that has storage capacity should continue to store rather than hog up the interceptor. Last thing that we're working towards in terms of making this story more of a saga is taking that real-time data across the entire system so that we can control the most impactful outfalls. And then accounting for the spatial variation of rain, gain basin-wide coordination, not just of a couple facilities, but just a couple facilities that we have built now. But as we build more facilities, we continue to incorporate those into our control algorithms and allow the SCADA system to optimize that so that we are only building what we absolutely have to and getting the most out of the assets that we have built and the ones that we build in the future. So the story I told you was about Cincinnati. We had a massive challenge. We had an expensive, long-standing, long-reaching consent decree. And so we developed a new approach that was to control the watershed. And we leveraged technological innovations to do that. New sensors, telemetry, a SCADA system, a cloud-based SCADA system. And what that has led us to is a new solution. We're getting quicker results that we're already seeing, and lower costs into the future.
Hey, Reese, before we get to the very last part of your presentation, just a quick question from the audience. Does GIS play a role in this solution? And if not, are there plans to integrate GIS into this solution?
We early on looked at the different visualization methods, and since we were going with the GE Prophecy suite of products, the visualizations are not GIS based. They are like watershed by watershed, because just based on how we were breaking down watersheds, we did a watershed per screen, and that's static versus GIS, which would be more dynamic. Now, we have other systems that keep track of where our sensors are and other kind of relational data, different than time series data. And those systems do have a GIS interface and visualization. But in the SCADA system, there's no GIS, I guess, interplay, and there's not plans to do that anytime soon.
Thank you.
So I'm sharing this with you, not just because I'd like you to learn about Cincinnati, but because I think this can be done in other cities. And so I offer the template for you to take this to your city and examine what's your challenge. What approach can you take that's new? How can you use technological innovations to come up with a new solution? Here are some ideas and tips that we learned along the way here. Look at your existing assets. If you're already got concrete and steel in the ground, the best investment you can do is get every drop out of what you got. So our initial focus was always look at our existing assets and find out how we could maximize their performance. Ask relatively simple questions. Ask those questions that might seem kind of silly, or you're afraid to ask. Ask them. See if you can do it. Hey, what if we controlled the collection system like we controlled our treatment plant? We've been doing it at treatment plants forever. Why can't we do that in our collection system? Demonstrate. And start small. As I illustrated as our sensor network grew, it wasn't 600 sensors on day one. We started with a small set along our interceptor to begin gathering information, to begin getting data, and that very quickly illustrated how valuable it was. And enabled us to expand because we were able to take that data, turning it into information, improving performance, and that became a very virtuous cycle of being able to expand, find future benefits, and now the additional operational changes we make are on the back of the investments already made. And so the costs continue to stay at extremely low levels because we're leveraging the sensors that are in. Leveraging the cloud. The cloud provides great power, also additional risk, which needs to not be taken lightly, but can be leveraged. The cloud enables scalability and the ability to tap into the capabilities of software designed for the cloud that can rapidly expand and contract to adjust to your needs. Last, always measure the benefit. It was critical for us to measure the improvements we were making in our operations to demonstrate that these investments were worth it. They clearly were, but you have to be able to measure the benefits to communicate that. I appreciate you listening to the story of the smart sewers in Cincinnati. I took one question already about GIS. I'm sure that was one that was a hot topic. If I wasn't clear enough, I'm happy to answer it again, or any other questions that are out there. Thank you.
Thank you, Reese. That was great. Yeah, just as a reminder, people can submit questions in the questions panel, and we've got quite a few of them. So I think this one, Reese, would be for you first. One of the audience members is asking, what type of gate valves are you using to control flow to the interceptor sewer? And then it's kind of a two-part question. Are they remotely controlled through SCADA? Have there been any issues with corrosion? And does the city cycle them on a regular basis to ensure they operate when they need them to open or close?
Okay, lots of questions there. The first one is the facilities that we have out there now that were first installed were were real-time controls facilities that used inflatable dams and large metal flap gates that were latched mechanically. So they're different than like a sluice gate or some kind of slide gate. And those so they're different. They are all. The other question was, are they remotely controlled? They're all remotely controlled. To be more specific, they're actually controlled by a local PLC that was installed at the facility with those, with that inflatable dam or with the latchable gates, where we are now installing those dynamic underflow controls. Those are sluice gates. I don't know the manufacturer of those, but those are actuated. They're actuated via a local PLC that is talked to by the SCADA system, and the SCADA system automatically would close those. I think I get all the parts of the question there?
I think you did it. Yeah, that's the hat trick.
Okay.
Absolutely.
I hope so.
Yeah. So another one, Kevin is asking, what GE products do you use? Predix, HMI, Historian? Can you kind of go through those for us?
Sure. The three that we're using right now are the iFix, the iHistorian, and Workflow.
Great. And then we have some other software questions too. So what software is used for facility intercommunication and controls? Custom programming or customized product?
So let me think about it. So the control of the facility, these larger remote facilities that have PLCs at them, is that what they're? Those are that's SCADA. It's the GE SCADA software that's running
Sure.
those PLCs, even at the remote facilities. Actually, I'll take that back. Some of the facilities that are smaller, they were put in with like these real-time control facilities. They have like a there's like a system that was installed to control the blowers and inflate the dam, for example. That is not technically GE software. I don't know what it is. It was whatever provided by the manufacturer of that system. But then it talks to a PLC that then talks to the cloud SCADA system.
Sure.
That's probably the best.
A couple other questions. Doris is asking what type of flow monitors you're using and also what type of level sensors.
I wish I had my remote monitoring lead on the call because he would be able to answer the specific brands and such, which is probably what you're interested in. We have an array of them. I know we use a lot of ISCO flow monitors, and then the level sensors. We use both pressure and ultrasonic, the two different technologies I recognize. I couldn't give you a brand name, but if you contact me afterwards, I can connect you with our remote monitoring group who knows the ins and outs and the specifics of the different sensors. I'm lucky. I get to be kind of agnostic to that, and our sensor team does a phenomenal job of getting data. They know what type of sensors to use, how to install them, how to make sure that the excellent data is being produced, and then I feed that into the SCADA system. So I'm very lucky to have a very strong sensor team supporting me.
That's great. And you touched on this during your presentation, but what are some of the cybersecurity precautions when you're involved in the cloud that you've taken?
Sure. It wasn't something we took lightly, for sure. But the way we started that conversation was around recognizing our risk profile. So when we started down this journey, we said, we're not intending to take the major treatment plan, any of our major treatment plants. Our largest one treats, the bulk of the daily flow. It would be a major public health disaster if that was in any way compromised. And so we didn't start there. We didn't say, hey, let's put that on the cloud. Instead, we said, let's look at our risk profile. What happens if we took one of these remote facilities and it was compromised? And we went through some of the scenarios of what would happen. And we weighed that against, and these are facilities that are remote from the plant, not downtown in an area that's has massive risk of human contact or impact. And if there was a compromise, the outcome was, well, there was more overflow there than would have happened, before we put something there. So it was a minimal additional risk, but we gained so much by being able to have our operators and our maintenance crews and our managers being able to run that facility better, that it was the cost benefit there was easy to see that it was worth taking that small additional risk for the additional improvement in performance that we could gain. Now, again, we did not take that lightly, even though we did kind of a risk analysis of the assets that we were proposing to put in a cloud-based system. We also worked very closely with our IT department to make sure that we were doing that in a secure manner. We use, I'm not a IT expert, so I don't know all the details, but I know it's highly secure, and I also wouldn't make sense to explain all of the things we've implemented. But we worked closely with our IT department to make sure that we were enforcing security using VPNs and also secure software that allows for authentication of each and every user. Even when I'm sitting here at my desk at the plant, I have to log in and fully authenticate to get access to the system. That's the best I can answer there, and the details there I'll leave to IT.
No, that's good. Thanks for taking us through that. This next one, I know that you and I have talked about before. Christine's asking, how are sensors connected to the cloud? Are they all cellular?
All of our remote sensors, so if it's not at a treatment facility or a remote treatment facility, connect through that RTU that we went out and did a competitive bid for. That RTU does connect cellularly to through the cloud, and then we access the data that way. So it's all
Gotcha.
the short answer is cellular, which allowed us to leverage the existing network here in Cincinnati. We've experimented and played around with a couple other technologies that, you know, promising lower battery usage and are very intriguing. We're still always, you know, looking for improvements, but we found that was the best system for us to use. There's also a lot of hills here, so we've, you know, exploring line of sight radios and other things just wouldn't work in this environment. So that's why the cell network ended up being the kind of the telemetry of choice for us.
We got a lot more questions coming in. Reese, I know you alluded to this during the presentation, but how does Cincinnati tie in the weather forecast or weather data, you know, to predict and control flows in the sewer system?
Great question. In our SCADA system, our home screen, which shows our whole service area, we pull in a product that's provided by one of our vendors that they're experts in rainfall analysis, and they provide us near real-time radar data, and we overlay that on our SCADA system so that we can see in near real time what's going on. We're moving towards the place where we're pulling in weather predictions. At this point, we sit down once a week and look at what the weather's predicted to be and make sure our facilities are ready in anticipation of that. We found that the weather forecasting farther than 2 or 3 days out isn't as reliable as we'd like it to be. So there isn't much benefit yet to us pulling that into SCADA directly. The other thing that we found is that the amount of travel time we have in our sewers, several hours, in fact, you know, to drain our largest interceptor system can take up to a day or even longer. We have sensors far enough above our control facilities to be able to get the data to make the decision that we want to make before we need to have that data, if that makes sense. It's like the event horizon. If we only need 3 hours heads up to make a change at the plant, then we have 3 hours worth of travel time within our sewers, so we put a sensor 3 hours up and can see what's happening in anticipation of what's going to hit the plant in 3 hours, for example. So right now we don't have predictive weather in there. We're going to get there, but right now we have enough travel time in our sewers to help us make decisions.
Makes sense. Reese, did you have to add any staff to administer the additional sensors? Frank is asking.
No, we were able to leverage and reform our internal resources. In fact, we found cost savings. We were using a lot of contract resources, and we were able to, as I showed in the slides, able to reduce our spend on external contract resources because we were managing the data much more effectively. Before, you know, we had to have a lot of teams that were just able to respond, and since we were monitoring the data in real time, we're able to see if sensors go down or if they need a new battery or if the sensors starting to act up, and we dispatch crews. So actually saved contract money. But in terms of headcount, no, we didn't increase. In fact, we had to use what we had internally.
Makes sense. Another question, and Alan, you can chime in on this as well. because it applies to Cincinnati and other systems. But, how do you get buy-in from leadership to pursue a solution like this? I know you mentioned some of the savings from optimizations, but, those can't all be clear right up front, right? Some of those come from a result of a pilot or a test. So how do you get that buy-in initially?
So I'd offer that it's critical to get that buy-in. And it's important to keep your leadership, informed of what you're doing and understanding the benefits. And it helped, like I said and near the end there, it helps by starting small and demonstrating those benefits. There's nothing more powerful than going with numbers that say, look, there's additional capacity. We're taking advantage of that capacity, and here's what those savings are. We were very lucky here in Cincinnati to have a leadership that saw that, intuitively knew that this was the right thing to do, could see that those benefits would come from it, and saw that this was definitely worth the investment. Alan, you can feel free to chime in.
No, I think that's the case. When we spoke with Bijou a number of years ago, the easy answer was, let's just dig a bunch of tunnels, pour a bunch of concrete, and solve it in a very traditional way. And I think that having a solid story around how you automate and solve and what it's going to work really helps. And then that's where we see a lot of the challenges that go into these. Is there's the obvious answer, which sometimes involves a lot of construction, a lot of those pieces. But what we see many utilities doing is sometimes overstepping. Hey, if we just do more of an investment on our automation, if we do more of an investment here, there's some bigger gains. And often those play in parallel. Sometimes let's automate it. But I think that's the biggest deal, is someone in the room has to say, hey, let's put a pause on the backhoe showing up and see if we can solve this in a different way. And that's what they had at Cincinnati at the beginning.
Yeah, it takes a little bit of you got to get buy-in, you got to have some trust there, demonstrating results. But when you can show things that are pretty intuitive, hey, let's not have an overflow if we have room in our pipes, and we can use that by technology rather than more concrete and steel. It's an easier story to tell.
I think we have time for maybe one or two more questions. Reese Travis is asking, is the cloud SCADA system you mentioned iFix, and are you hosting on-premise?
So, the SCADA guys would probably correct me, but I think we use SCADA and all these terms kind of interchangeably. So we have iFix, iHistorian, and Workflow as three GE products that are installed on servers they're cloud enabled. Essentially, they're connected to the internet. They happen to be hosted on our internal facility, or our data center here at the facility. So they're not like on AWS or hosted somewhere in Neverland. It's a little piece of cloud that is in our data center.
Okay, and I think I'm going to make this our last question. I'm sorry we couldn't get to everybody's questions. We have a ton of them here, and so thank you to everybody. But the last one, I think this is a good one, Reese. Do you ramp up treatment plant production / capacity in advance of storm flows or actual level in the sewers to dewater the sewers for maximizing storage, or do you ramp up during actual storm events?
We try to anticipate those. Actually, one of the very first things, and this gets to back to the buy-in question, actually, so this is a good example. One of the very first things we did was when we figured out, okay, we're going to put some sensors out in the system for our purposes to start optimizing the system. And we're like, well, wouldn't the treatment operators like to know what comes to their plant, and they do. And so we went to them and said, hey guys, would you like to know what flow is coming down the pipe towards you? You have 4 different interceptors, they all hit you, you're kind of blind. I mean, you watch the Weather Channel, but hey. And they said, that would be great. And I said, okay, what do you need? 4 hours, 6 hours? And they said, we need about 45 minutes. So we said, okay, we'll put sensors that can tell you 15, 30, and 60 minutes out on each of your major interceptors coming to your plant, to the first treatment plant we worked with, to tell them what was coming at them. And they said, that's great. That enables them to anticipate and get additional trains online prior to the storm hitting. As we do more of the automation of the remote facilities, yeah, we use the data to say, okay, we need to have this dewatered before we get the next storm, but that's in the future. Right now, the assets, will wait until the storm has passed and then either dewater or release the flow back into the system.
Great, thanks, Reese. Reese,
the tie-in with the buy-in was, the tie-in with the buy-in was, now we were providing benefit not just to what we initially intended to do, but to a whole other division, and that helped to say, gosh, we're getting a lot out of this. And so management and other divisions were like, okay, this is going to help. So sorry to jump in there, but I wanted to make the connection.
No, that totally makes sense. Thank you for that. Reese, thanks so much for joining us today for the panel and taking so many questions. Reese Johnson and Alan Hitchman of GrayMatter, thank you both for being panelists today. I want to thank you for joining everybody, for joining the webinar. Don't forget to participate in the survey immediately following the webinar. And please check out graymattersystems.com and check out our upcoming in-person Tech Talk and tour at Bonita Springs Utilities. It's December 5th. You can sign up for free if you're in Florida, especially. Take advantage of that. So thank you, everyone, for joining us today, and thank you again for all of the questions.